Hi, hello. In this video, we are going to understand an important concept in hypothesis testing, type 1 error and type 2 error. Generally, in any business, we do experimentation to understand about a population. That means through experimentation, we collect a sample data. Using the sample data, we try to, understand a population. Let's say you produce a lot of product every single day. Let's say every single day you produce 10,000 product, and then you wanted to know whether the 10,000 products will be good or bad. So what do? You study on a small number of samples, and let's say you study, using 100 samples, and based on the 100 samples, how the sample characteristics are. If all the 100 samples are good, probably you will judge that, all the 10,000 units you will be producing will also be good. But always, this is called a sampling study. Always sampling study will have certain limitation, right? Sometimes what you observe in the sample may not actually happen in the population, right? What you observed in the sample sometimes may not happen in the population, right? So that will lead to the sampling error, and we call them as type 1 error and type 2 error. And that is what we are going to understand in this particular video, type 1 error and type 2 error. In the process, we will also understand confidence level and power of test, right? Let us proceed. And in order to understand type 1 and type 2 error, first let us consider a manufacturing scenario so that you can easily grasp the point, and then we will connect our understanding with hypothesis testing. So in a manufacturing environment, let us say, the products the products you produce are really good. The products you produce are really good, but your quality inspectors, they check all your good product, and then they reject them. Your product is good, but your quality inspectors, they check the product, and then consider those product as bad, and then they reject. Maybe it is due to some limitation in the study. They took a small sample, and the sample units are found to be bad. And so what happened? They have rejected your entire lot of products you manufactured. That means a sample is studied, and in the sample some defects are noticed, and based on the sample they rejected the entire lot. But the reality is the entire lot is extremely good, but in the sampling they observed few defects. These are all possible, right? And as a result, a good lot is rejected due to a bad sample. And this is called manufacturer's risk. Why we call it manufacturer's risk? Because the entire unit in your lot is very good, but only in the sample few defects are found. As a result, the entire lot is rejected. Now who is under risk? The manufacturer is under risk. This is called manufacturer's risk. This is called manufacturer's risk. And if this error happens in a sample study, that error is called as type 1 error. That error is called as type 1 error. So always any sample study will have some limitation. The limitation is it will have some error, and one of the error is type 1 error, and the risk is definitely involved. And how much risk you are ready to tolerate, and that is the bigger question, needs to be understood whenever we go for a sampling study. So hope you have understood the manufacturing risk. So let us say the manufacturer risk is 5%. That means 5% of this time your sample and population, what you observe in the sample and what you observe in the population can be different. Your sample says, product is bad, and so you rejected a lot. But actually the population is good. So 5% of the time, if there is a contradiction between, what you observed in the sample and then what is there actually in the population, that is tolerable. That permissible level is called manufacturer risk, and that is given a symbol alpha. This must be fixed right at the beginning stage of the sampling study. If the manufacturer risk associated is 5%. It simply means remaining 95% of the time, whatever you observe in the sample will exactly reflect in the population. That means, 95% of the good lot is accepted based on the sample study. See here, the lot is good and it is accepted all remaining 95% of the time. This 95% is called confidence level. So what is confidence level? The ability of your, sampling study, right? Where what you observed in the sample and what you are going to observe in the population are same. So you accept a good lot as good only. The lot is good and you also accept it as good lot based on the sample study. Because in the sample also you got some, good products. So as a result, you accepted the good lot almost, 95% of the time. That is called confidence level. So whenever you say the confidence level is 95%, it simply means you have 5% of manufacturer's risk in there, in it, isn't it? Or otherwise, whenever you say the manufacturer risk is 5%, that means your expectation on the confidence level is 95%. Hope it is clear. So the manufacturer's risk is denoted by the symbol alpha, and so the confidence level will be 1 minus alpha. Coming on to the other side, let us say the lot is bad and you tested a sample, and based on the sample you rejected the bad lot saying that it is bad. So bad is rejected as bad. This is called power of test. This is called power of test. But sometimes what happens, based on a sample, you might accept a bad lot. You took a sample and sample was good. So you actually accepted the lot, but the lot is completely bad. So a bad lot is accepted by you. There is a risk here. When you accept the bad lot, you know what will happen? The bad lot will finally reach the customer. So now the consumer is under risk. So the proportion of time your sample study, fail to detect a bad lot and then end up accepting a bad lot is called consumer's risk. This should also be, admitted, and this should also be fixed right at the beginning of the sampling study. Always sampling study will have these two risks involved. So we must admit them. We must fix them. We must, declare them before, generating a report based on our sampling study. So if the consumer risk is, let us say 10%, that means 90% of the time you correctly reject a bad lot. So that is called power of test. If the consumer's risk is 10%, then power of test is 90%. Hope you have clearly understood what is manufacturer's risk and what is consumer's risk. If I reject a good lot, it is manufacturer's risk. If I accept a bad lot, then it is consumer's risk, isn't it? If the manufacturer risk is 5%, then confidence level is 95%. If the consumer risk is 10%, then the power of test is 90%. See here, whenever you do a sampling study and then you take a decision on the population, whether the population is good or bad, the decision is, depends on sample size. More the number of sample, your decision will be more perfect, isn't it? So sample size is one thing, and then what is the confidence level you want to achieve in your decision? So that confidence level also another important variable, and then power of test is another important variable, and then the difference in the statistics you want to validate. So these four actually, trigger the decision, right? And particularly this last factor will be very much applicable to hypothesis testing. We will be, understanding it in the subsequent slide. Now, the same type 1 and type 2 error in terms of hypothesis testing. When it comes to hypothesis testing, we are going to judge on the trueness of the null hypothesis. In case of manufacturing, we judged on the nature of the lot, whether the lot is good or bad, and we easily understood. Now, we are going to judge on the hypothesis statement, particularly null hypothesis. So the reality about null is written in the x-axis, and your decision is expressed in the y-axis. See here, your null hypothesis is true, but you are rejecting it. And this is called type 1 error. This is called type 1 error, and generally the permissible amount of type 1 error is fixed in any sample study, in any hypothesis testing. Let's say I am fixing it as 5%. That means I am okay to tolerate a sampling study limit, sampling error of 5%. That means I am okay to tolerate a sampling error of 5%, which is known as level of significance. You should first fix the level of significance, and which is here fixed as 5%. If the level of significance is fixed as 5%, it simply means your expected confidence level, right, is 95%, because you mentioned that your level of significance is 5%. It means the expected confidence level is 95%. So that means when the null hypothesis is true, right, and still you reject it, and you are now committing a type 1 error. So what is type 1 error? A true null hypothesis is getting rejected. Then what is confidence level? A true null hypothesis is accepted as true. A true null hypothesis is accepted as true based on the experimental study. And the proportion of time a true null hypothesis is accepted as true is called confidence level. So when the level of significance or the alpha risk is accepted to be 5%, then immediately the expected confidence level is 95%, right? If a type 1 error of, let's say, 5% is observed, that means you have achieved a confidence level of 95% based on the experimental study. Suppose if the estimated type 1 error is 10%, it simply means you have achieved a confidence level of 90% only. Now, coming on to the other side, let us say your null hypothesis is false and you correctly reject it. Null hypothesis is false and you correctly reject it. That is called the power of test. That is called power of test. That means the other possibility is also there. The null hypothesis is false, but you still accept it. Null hypothesis is false, but you still accept it as true. That means you are committing type 2 error. The type 2 error also, there is a permissible level, what we call it beta risk. So beta risk should also be fixed. If we fix beta risk to be, let us say, 10%, that means the expected power of test is 90%. If the estimated type 2 error is 10%, that means the power of test attained is 90%. So hope you have clearly understood. Generally, in any hypothesis testing, in any sampling study, you should be able to achieve 95% confidence level. That means the alpha risk should be limited to 5%. Then only you can say the confidence level is 95%. The estimate of alpha risk, right? The estimate of alpha risk is nothing but type 1 error. Your null hypothesis is true, but you still reject it, which is called type 1 error. If the type 1 error is limited to 5%, that it simply means you have achieved a confidence level of 95%. Please note there are two terms I am using here. One is risk, another one is error. You know what is risk? The permissible error. Then what is error? The actually committed or the estimated error. So risk means the tolerable limit. Error means the estimated error, right? So based on the sample study, once the data is available, then you can make an estimate on the type 1 error. There are certain statistical procedure. So what you have estimated is error and what is permissible is risk. So alpha risk is very important. Alpha risk in hypothesis testing is also known as level of significance. If the level of significance is 5%, you can immediately understand your company wants 95% confidence level from your experimental study. And as I already explained, always the decision on any hypothesis testing is a function of sample size, confidence level, power of test, and statistics to be validated. So these four are interconnected. If you want more confidence level, probably more sample size is required. And then if you need more confidence level, probably it will affect your power of test. And also the statistics, the difference in the statistics to be validated. If the difference is too large, probably you can validate it with a simple lower sample size. But if the difference is very narrow, then you might require a higher sample size to achieve the required confidence level. So there is some relationship within this four. You can assume any three, and then the fourth one will be automatically fixed. So we will discuss all these things probably at a later stage. So hope you have clearly understood here what is type 1 error and what is type 2 error. If you reject a true null hypothesis, it is type 1 error, isn't it? If you accept a false null hypothesis, then it is type 2 error. Type 2 error is also known as alpha risk. Type 2 error is also known as beta risk. If the alpha risk is 5%, then the confidence level is 95%. Similarly, if the beta risk is 10%, then the power of test is 90%, right? So hope the lessons you are able to understand very clearly about the type 1 error as well as type 2 error, and we will be using this knowledge in the upcoming topics, upcoming hypothesis testing on the mean and testing of proportion. When we are actually conducting the hypothesis testing, we'll use all these tools, right? Thank you for watching, and I'll see you in the next video.